This is the pre-lecture video on the ADAS model for the course Global Business Economics. I'm David Frankel, a professor at Melbourne Business School. Here we go. In a previous video, we studied business cycles using the aggregate expenditure model. While that model is relatively simple, it has an important shortcoming. It takes prices as fixed. So it cannot be used to study the important phenomenon of wage and price inflation. Moreover, it's relevant only to the very short run in which firms do not have time to change prices, a period of days or at most a week or two. In this video, we will study a much richer model, which is called the ADAS model. In this model, prices can change. Thus, the model lets us analyze changes in both output and inflation over the business cycle. We shall see that the model provides a convincing explanation of the business cycles of recent decades in which inflation played a prominent role. Like a model of supply and demand, the ADAS model will have two curves. One, the aggregate demand, or AD curve, will be downward sloping, like a demand curve. The other, the aggregate supply, or AS curve, will be upward sloping, just like a supply curve. Moreover, the equilibrium will occur at their intersection, just like regular supply and demand curves. However, that is where the similarity ends. The differences will become clear as we define these curves and study their properties. To depict the economy, we will use the diagram that appears on the right. Output Y appears on the horizontal axis and inflation pi appears on the vertical axis. The horizontal dashed line is the line at which actual inflation pi equals expected inflation pi e. We will call this line the expected inflation line. The vertical dashed line is the line at which output y equals potential output y star. We will call this line the potential output line. In this diagram, we will next draw the AS curve. Luckily, the AS curve is easy to grasp. It's simply the Phillips curve that we studied in a prior video. The Phillips curve equation states that inflation pi equals expected inflation pi e plus a positive constant gamma times the output gap, which in turn equals y minus y star divided by y star. That is, the output gap is the percentage by which actual output exceeds potential output. It is positive in a boom and negative in a recession. The fact that the constant gamma is positive means that an increase in output y leads to an increase in inflation pi. Hence, the AS curve is upward sloping in the diagram. Moreover, if you substitute y star for y in the Phillips curve equation, you find that inflation pi must then equal expected inflation pi e. This implies that the AS curve must always pass through the intersection of the expected inflation line and the potential output line. I'll say this again. The AS curve must always pass through the intersection of the expected inflation line and the potential output line. This fact is the key to understanding the behavior of the AS curve. To emphasize it, we will always draw these three items in the same identical color. We now turn to the other curve, the AD curve. While the AS curve shows how output affects inflation, the AD curve captures the reverse effect, how inflation affects output. Empirical studies suggest that this effect is negative. This is partly because inflation causes people to waste time trying to protect their wealth rather than producing output. In addition, inflation leads central banks to raise interest rates, which also lowers output, as discussed in the Fisher equation video. For these reasons, the AD curve is downward sloping. The intersection of the AD and AS curves will play an important role in our model. This intersection is what determines the actual inflation rate pi and the actual output level y. As shown in the diagram, actual inflation may differ from expected inflation, and actual output may not equal potential output. There is, however, one situation in which they are equal, in the economy's long-run equilibrium. We define the long-run equilibrium as a situation in which the economy has settled down, fluctuations have ended. In particular, the inflation rate is constant from one period to the next. In such a situation, it's reasonable to believe that consumers and firms will learn to predict inflation perfectly. Actual and expected inflation will be equal. But actual inflation is determined by the intersection of the AD and AS curves. So this intersection must occur somewhere on the expected inflation line as shown. Exactly where on the expected inflation line do the AD and AS curves intersect? Well, we already know that the AS curve must intersect the expected inflation line at the potential output line. Thus, the only way in which the AD curve can intersect the AS curve on the expected inflation line is if it, like the AS curve, intersects the expected inflation line at the potential output line as shown in the diagram. This is the key distinguishing feature of the long-run equilibrium. This also has another interesting implication. In long-run equilibrium, output Y must equal potential output Y star, or equivalently, the output gap must be zero. In contrast, the aggregate expenditure model does not predict the long-run output gap. That's an important advantage of the ADAS model. It allows us to make long-run predictions. We now know enough about the ADAS model to begin studying business cycles. We start with a recession that is caused by a decline in autonomous spending. For instance, the bursting of an asset bubble may cause a decline in consumer sentiment or in firms' planned investment. This is called a demand-driven recession. It's widely believed that the Great Depression and Great Recession both began in this way. When our story begins, the economy is in long-run equilibrium. The AD and AS curves intersect at point A, which is also where the expected inflation line intersects the potential output line. Thus, inflation and expected inflation are equal, and the output gap is zero. Suddenly, the demand shock hits. The shock appears as a leftward and downward shift in the AD curve as shown. This shift means that for any inflation rate, the economy now produces less output. There is no change in potential output Y star, and, at least initially, no change in expected inflation pi e, so the AS curve cannot move for now. The economy thus moves to point B, at the intersection of the new AD curve with the AS curve which has not moved. Comparing point B to point A, one can see that the initial demand shock causes inflation to fall, so that it is now below expected inflation, and also causes output to fall below potential output. The output gap is now negative. A recession has begun. Consumers and firms then gradually become aware that inflation is lower than they expected. This leads them to expect less inflation in the future. The expected inflation line falls. This in turn causes the AS curve to fall by the same amount, since the AS curve must always go through the intersection of the expected inflation line and the potential output line. The fall in the AS curve, in turn, causes the economy to move down the AD curve as shown. Inflation continues to fall while output rises. A recovery has begun. This process of declining inflationary expectations must continue until finally expected inflation catches up with actual inflation. When does this happen? We can use two facts to figure this out. First, Actual inflation is always given by the intersection between the AS and AD curves. Second, expected inflation is always given by the intersection of the AS curve with the potential output line. So, the only way that expected inflation can reach actual inflation is if the AS curve passes through the point where the AD curve intersects the potential output line. This appears as point C in the diagram. Let's now take stock of what we've learned about a demand-driven recession. Initially, the economy is at point A, where output equals potential output. Then a demand shock hits that lowers the AD curve. The economy moves rather quickly from point A to point B. This means that both inflation and output decline. Consumers and firms then notice that inflation is lower than they expected. They lower their inflationary expectations, causing the AS curve gradually to fall until it intersects point C. The decline in the AS curve causes the economy to move slowly down the AD curve from point B to point C. As a result, inflation continues to fall while output stages a recovery. It gradually rises until it once again equals potential output. In practice, this recovery can take many years. While demand-driven recessions can be very painful in the short run, the long-run picture is actually not so bad. The new long-run equilibrium features lower inflation, but output has returned to its initial level. Thus, central banks have actually caused demand-driven recessions intentionally in order to reduce persistently high inflation. We now turn to a different type of recession, one that is caused by a negative shock to potential output Y star. We will see that these recessions have no such advantages. Rather, in the long run, they lead to higher inflation and lower output. One example of a supply-driven recession was the oil price shock of 1974. This sharp increase in oil prices led to a decline in potential output. There are a few reasons for this. First, there are some goods and services that are only profitable to make if energy is cheap. Higher energy costs prevent these goods and services from being produced. This lowers potential output. Second, as you can see in the picture, drivers wasted considerable time queuing for petrol. Those who were unable to get petrol were unable to commute to work. Let's now use the ADAS model to analyze a supply-driven recession. Once again, we begin with the economy in the long-run equilibrium. The AD and AS curves intersect at point A, which is also where the expected inflation line intersect the potential output line. Thus, inflation and expected inflation are equal, and the output gap is 0. Suddenly, a supply shock hits. This lowers potential output Y star, moving the potential output line leftwards as shown. Because the AS curve must pass through the intersection of the potential output line and the expected inflation line, the AS curve must move leftwards in lockstep with the potential output line as depicted. The new equilibrium is at point B. Relative to point A, one can see that inflation has risen and output has fallen. This phenomenon, high inflation during a recession, is called stagflation. Note that in this new situation, actual inflation pi exceeds expected inflation pi e. Consumers and firms begin to notice this. They raise their expectations of future inflation. These higher inflationary expectations take the form of an upward movement in the expected inflation line as depicted. By its nature, the AS curve must rise in lockstep with the expected inflation line as indicated by the arrows. This rise in the AS curve, in turn, causes the stagflation to worsen. As the economy moves up the AD curve, actual inflation pi rises further and actual output continues to fall. This process of rising inflation and rising inflationary expectations must continue until, finally, expected inflation catches up with actual inflation. When does this happen? As before, we can use two general rules to figure this out. First, actual inflation is always given by the intersection between the AS and AD curves. Second, expected inflation is always given by the intersection of the AS curve with the potential output line. So the only way that expected inflation can reach actual inflation is if the AS curve passes through the point where the AD curve intersects the potential output line. This appears as point C in the diagram. Let's now summarize what we've learned about a supply-driven recession. Initially, the economy is at point A, where output equals potential output. Then, a supply shock causes the potential output line and the AS curve to shift to the left. The economy moves rather quickly from point A to point B. Inflation rises and output falls. Stagflation begins. Consumers and firms then notice that inflation is higher than they expected. They raise their inflationary expectations, causing the AS curve to rise. This rise, in turn, causes the economy to move slowly up the AD curve from point B to point C. As a result of this movement, the initial stagflation gets even worse. Inflation continues to rise, while output continues to fall. These negative long-term effects of supply-driven recessions contrast sharply with the beneficial long-term effects of a demand-driven recession, which ultimately leads to lower inflation with no change in output. The key takeaways from this video are as follows. We studied two types of shocks. First, a negative demand shock initially lowers both inflation and output. Inflationary expectations then begin to fall. This lowers actual inflation further, but actually raises output. A recovery is underway. In the new long-run equilibrium, inflation is lower than before, but output is unchanged. Thus, a demand-driven recession has long-term effects that can be beneficial, particularly in countries with stubbornly high inflation rates. But the short-term effects, lower living standards and higher unemployment, can be quite painful. The second type of shock we studied was a supply shock. Like a demand shock, a supply shock initially lowers output. But in this case, inflation initially rises rather than falls. This phenomenon of rising inflation in a recession is called stagflation. As inflationary expectations rise, actual inflation continues to rise while output continues to fall. The stagflation gets even worse. In the new long-run equilibrium, inflation is higher than before, while output is lower. Hence, it is hard to think of a situation in which a supply-driven recession could be seen as beneficial. This concludes the pre-lecture video on the ADAS model. Thank you for watching.